to integrate cosine to the power 4, it's not straightforward. It's not like the differentiation of cosine to the power 4. You can't simply add 1 to that power. So we need to simplify this, and there's going to be some kind of trigonometric identity involved. So the trick is, whenever you have a sine or a cosine squared, you use the double angle formula. And I think the first thing you'd want to do is turn the cosine to the power 4 into cosine to the power 2. So you can say this is cosine squared x squared, because we sort of know how to deal with cosine squared x. And I'll remind you how to do that. So there's some identities you're expected to know. So you're expected to know that sine squared x plus cosine squared x equals 1. And you're expected to know the double angle formula, cosine 2x equals cosine squared x minus sine squared x. And if you replace sine squared with 1 minus cosine squared, you end up with cosine 2x equals 2 cosine squared x minus 1. You can rewrite that as cosine squared x equals 1 plus cosine 2x divided by 2. And that's really helpful. All right, so that identity, you either remember it or know how to derive it. So that is a really helpful identity, and that's how we would deal with the cosine squared. So I'm going to replace my cosine squared with what I just discovered, which is 1 plus cosine 2x divided by 2, and all of that is going to be squared. So this squared is that. This squared we have eliminated. So we've essentially reduced the power. We've reduced the power from 2 to 1. So it was cosine to the power 4. Now it's cosine to the power 1. We still have a squared, but I think we can deal with that in a similar way. So how do I deal with this squared? Well, I don't know, but what I could do is just expand these brackets. So that's worth trying at least. I can write it out as 1 plus cosine 2x over 2 times 1 plus cosine 2x over 2 dx, and see where that takes us. These 2's are annoying. Let's just multiply the two 2's into 4 in the denominator, and then we have something a little bit more manageable. Okay, so now we can expand the brackets by multiplying all these terms. So most of the terms will be easy. We'll still have a cosine squared, but then we can use this identity again to fix that. So we're going to have 1 over 4 times the integral of 1 plus cos 2x plus cos 2x plus cos squared 2x dx. Now, these two, we can add those together, they're like terms. And this one here, we can use the double angle identity. So I'll remind you that cosine squared x is 1 plus cosine 2x divided by 2. And I can simply use that identity to reduce the power. So basically I'm going to half the power. I'm going to turn the cosine squared back into a cosine. So I'll put the identity here. This is the identity I'm going to use. I'm going to use that there. But obviously here, instead of x, we're going to have 2x. So instead of 2x, we're going to have 4x. So I now have 1 over 4, 1 plus 2 cos 2x. So I've added these two. Now I have 1 plus cos 4x, because this angle is twice that angle. So here we've got 2x, so obviously it needs to be 4x here. Dx. So now I think we're ready to integrate. It would be nice if we could split this into two fractions, so I'll just write it out. That's 1 over 2 plus cos 4x over 2 dx. Okay, so that's where we're up to. And it's now really easy because we can integrate the 1, we can integrate the cosine, integrate the half. We can actually just add these two together. So let's just call that 3 over 2. And then we've eliminated the half. There, so much easier than it was. So our cosine to the power 4, we had a power 4, we reduced that to the power 2. Now we've reduced the power 2 down to a power 1, and now it's easily integrable. So I'm going to integrate each of these. So I have 1 over 4 multiplied by. The integral of cosine is sine, but then you divide by 2. Because you already have a 2, it just cancels. So it's 2 sine 2x divided by 2. The integral of a constant is simply the constant times x. The integral of cosine is sine, but then you divide by 4. And you already have a 2 in the denominator, so you end up dividing by 8. Close brackets. Plus c, and it doesn't matter if the c is inside the brackets or not. So finally, I guess we could multiply by a quarter. So we end up with 1 over 4 sine 2x plus 3 over 8 x, if I multiply this by this, and then 1 over 32 sine 4x plus c. And that now is your final answer. So whenever you have sine or cosine to the power, to an even power, power 2, 4, or 6, you can use that identity to reduce the power and make something that isn't integrable easily integrable. I hope you found that helpful.